Basically, if you can substitute into a formula, you can do binomial probability. Everybody can substitute into a formula? Okay. Refers to the probability of exactly R successes on n repeated trials, highlight, in an experiment which has only two possible outcomes. That experiment is called a binomial experiment because there are only two possible outcomes. There must also be a fixed number of trials. Fixed number of trials, and the events should be independent. Okay, so looking at our little formula here, trying to break it down. If the probability of success on an individual trial is P, then the binomial probability is, okay, here's the first thing. So instead of using R for the smaller amount that you're choosing out of the larger amount, in stats they actually use an X, but it is just the same as what our R used to be. I'm going to write that here. It's R. That's also the stats way of writing a combination. Okay, so when you see an N stacked over an X like that, that's basically how we were doing when we had like N things and we're choosing R of them. Dink, dink, there we go, double arrow. Okay. That's just the stats notation, but it's just a combination of N total things and you're choosing this smaller amount of them. Okay, and then we have probability, which you'll be given to the power of whatever your smaller number is that you're choosing, times 1 minus the probability to the power of n minus x, which would be your larger minus smaller number. So again, it's just plugging into a formula. P is the probability of success of a single trial. So then 1 minus P would be the probability of failure on a single trial. We're first going to just think about whether or not these would be binomial experiments. Number 1, telephone surveying a group of 200 people to ask if they voted for Donald Trump or Joe Biden. What are we thinking? Yeah, because we need a fixed number of trials, and we need only two possible outcomes. Okay, so fixed number of trials, there would be 200 trials. These are our two outcomes. So this would be, yes, this would be a binomial experiment. Counting the average number of dogs seen at a vet's office daily. No, that one is not a binomial experiment. Not only are there probably not a fixed number of trials, there's also not just two possible outcomes. There's lots of possible outcomes, lots of dogs to choose from. You take a survey of 50 traffic lights in a certain city at 3 p.m., recording whether the light was red, green, or yellow at that time. No, what made it not a binomial experiment? There's three outcomes, right. It did have a set number of trials, but then that three outcomes is what made it not a binomial experiment. You're at a fair playing Pop the Balloon with 6 darts. There are 20 balloons. 10 of the balloons have a ticket inside that say win, and 10 have a ticket that say lose. Yeah, there's a fixed number of trials. How many trials are there? Bless you, bless you. Yes, good. And then the two possible outcomes are win or lose. So that makes it a binomial experiment. Okay, looking at our first one, we're actually going to calculate it. We're going to set it up the way Mr. Barnes has requested that I set it up. He has like a very specific notation that they use for AP stats, so I'll be setting it up like they set it up. So it says, what is the probability of getting 6 heads when you toss a coin 10 times? So he said he always starts by writing this line. This is a binomial with n equals, so this would be our total number of trials. What's our total trials? 10. Okay, I'm going to write that underneath. Total trials. Okay, and then the second thing he writes is the probability, which this would be the probability of getting heads. What is the probability of getting a heads on a coin? 1 out of 2, 0.5, however you want to write it. Do you want to write it as a fraction or a decimal?
Fraction.
Weird. Okay, alright, we're going to write it. Let's do it. Okay. And then the next thing he does is he starts setting up the equation. The first thing in the equation is probability of x. So x would be the smaller amount out of our 10 total trials. So we're trying to get the probability that that x is 6. Okay, so we want to get 6 of those heads out of 10 total trials. Okay, second part of the formula is writing the combination, and I'm going to write it in my formula with the official stats notation, which kind of almost looks like a fraction, but it's not. On the top, you would have your total trials, which is 10. On the bottom, you would have the smaller amount that you're choosing from that 10, which would be 6. And then we have times, and then we have the probability, which for us was just a half. So 1/2, can we write it as a decimal now? Yeah. Yes. Okay, so 1/2 to the power of x. What is our x? 6. Times, the second one would be 1 minus this probability, so 1 minus 0.5. And then this exponent would be our n minus our x, so 10 minus 6. Okay, so top number is n, bottom number is x, just FYI. I'm going to go over to the side and work out my combination. So I have this 10 choose 6 over here. I'm going to go work it out how we know how to work it out already. Remember, we usually write it as 10 choose 6 like this. And then in our formula, that would be 10 factorial over 6 factorial, and then 10 minus 6, which would be 4 factorial. And then how much of that 10 would we expand? Up to 6 factorial, 10, 9, 8, 7, 6 factorial, so that we can cancel the 6 factorial on the bottom. And then we also got 4, 3, 2, 1. Let's see, I could cancel my 4 and my 2 with the 8. I could simplify the 3 and the 9. So I really just have 10 times 3 times 7. 30 times 7 is 210. So now going back, I now know that this is 210. So I'm going to put that back in my formula, 210. And then I also have still 0.5 to the 6th power. And then I can simplify this, the 1 minus 0.5, which is 0.5. And then my new exponent on this would be a 4. 10 minus 6 would be a 4th power. And then from here, I'm just going to type it in my calculator. Everybody grab that calculator. We got 210. Daniel, you grabbed a calculator? Times 0.5 to the 6th power times 0.5 to the 4th power. There it is. And he told me when they get decimal answers that they round to 4 decimal places. That is the acceptable amount. So for us, that would be 0.205, and then the 7 will bump this up to a 1. 2051. No, not a 0. 2051. Which, as a percentage, just thinking about it just for our own interest, that would be 20 and almost like 20.5%. Seems high, but I trust it. Trust that formula. Wasn't too bad, right? You're really just plugging things into a formula, but the formula is new and weird and scary, but still not necessarily difficult. We're going to try the second one. Thanks so bad, Gene. Good. Okay. 80% of people who purchase pet insurance are women. If 9 pet insurance owners are randomly selected, find the probability that exactly 6 are women. Okay, so this is a binomial with how many trials? 9 trials, right? So this is our total. Okay. And the probability would be the probability of getting a woman, selecting a woman, which they told us directly, straightforward, is 80%, but we want to write it as 0.8. Very good. Okay, so setting up my formula, we're trying to get 6 out of those 9. So probability that the x is 6 would be, and then we'll have the stats notation for a combination, which would be 9 choose 6, like the 9 stacked on top of 6. 9 choose 6. And then we'll have the probability to the power of x. So we have the probability listed already. It's 0.8. To the power of x would be to the power of 6 times. And then we'll have 1 minus this probability. 1 minus 0.8 to the power of 9 minus 6. Okay, I'm going to go over to the side and figure out how much 9 choose 6 is. That would be 9 factorial over 6 factorial, and then 9 minus 6, so 3 factorial. So I'm going to expand enough of that 9 factorial to cancel my 6 factorial on the bottom. And then I also have my 3, which would be 3, 2, 1. Cancel. Let's see, the 3 and the 9 you could reduce the 2 and the 8. So we really just have 3 times 4 times 7. What's 12 times 7? 84. Very good. Okay, so I'm going to put that back in my formula right here. We know that's an 84 now. And we also have 0.8 to the 6th power times, and then we'll have 1 minus 0.8, which is how much? 0.2. 0.2 to the 3rd power. And then I'm just going to type it right into my calculator. My 0 looks weird because I tried to put a decimal point there and I didn't need it. Alright, let's see. 84 times 0.8 to the 6th power times 0.2 to the 3rd power is 4 decimal. Oh, did I type something wrong? Oh, what did I do wrong? Yeah, I put a 6 here instead of a 3. Let me get it back and fixed. There we go. And again, 4 decimal places is what is asked for in stats, so that would be 0.176. And then this 1, is it going to bump up or stay the same? It bumps up for that 6, right? Which would be 0.1762. As a percentage, it would be 17.62%. 80% of women, 9. Okay, all right, I believe it. I believe it. Doing okay?
Yes.
Thanks, Nick. I know. It's the first day Nick's not asking questions. Okay. I know the scariest part of this is just the formula, and spoiler alert, you get the formula on test. Is this going to be on today's quiz? No. Good job. Alright, the probability that a light bulb is defective is 10%. What is the probability that exactly 3 of 8 light bulbs are defective? Let's hope it's not a lot, because I would be mad if I bought light bulbs and 3 out of 8 of them were defective. Okay, starting with how many total trials we're going to have are in? 8. Very good. Okay, and then the probability is going to be probability of getting a defective one, which should be 10%, which is 0.10, 0.1, however you want to write it. Feels weird to just write 0.1. I feel like I need more. And then let's see. So we're trying to figure out the probability that we get 3 out of those 8 that are defective. So probability that our smaller number that we're choosing is 3. And then we'll have our official stats notation for a combination would be that we have 8 things and we're choosing 3 of them, stacked on top of each other, times, we'll have the probability of defective to the power of 3, because it's the x, good, times 1 minus that probability to the power of 8 minus 3. Okay, I'm going to go over here and figure out what 8 choose 3 is. 8 factorial over 3 factorial, and then 8 minus 3 would be 5 factorial. 8, 7, 6, 5. And then the 3 factorial would be 3, 2, 1. Cancel. Let's see, the 3 and the 2 I could just straight up cancel with the 6. So we'll have 8 times 7 left over. What's 8 times 7? 56. So we know that combination has a value of 56. So we'll have 56 times 10% to the 3rd power, so 0.10 to the 3rd power, times 1 minus 10%, which would be 90%. 90% is the probability of them not being defective. Thank God. To the 5th power for this one, 8 minus 3. Let's see. 56 times 0.10 to the 3rd power times 0.90, the not defective, to the 5th power. 0.0331 would be 4 decimal places. 0.0331. Is that what y'all got?
Yeah.
Go ahead. which as a percentage would be 3.31%. That's still higher than I want. I mean, I would love it to be 0%. I want to have 3 out of 8 light bulbs are defective. I feel like that's really high. I don't want to buy light bulbs and have them be defective. All right, anyone working ahead on the next one? Anyone notice what's different? Right, your percent is given to you as a fraction, specifically a fraction that you can't use a decimal with, so you're like forced to use the fraction. 2/3 of the people who purchase sports cars are men. Sounds right. Find the probability that exactly 7 are men if 10 sports car owners are randomly selected. So this would be a binomial experiment with how many total trials? 10, because that would be the... The probability of selecting a man sports car owner is how much? 2/3. Very good. Okay, so setting up our equation, we'll start with, we're trying to get 7 out of those 10. So the probability that x equals 7 equals, and the first thing is your 10 choose 7, your combination. You have 10 sports car owners, we're trying to get 7 of them. 10 stacked on the 7. Times, and then we'll have the probability of selecting a man, which is 2/3, to the power of x, which is 7, times, and then we'll have 1 minus this probability, 1 minus 2/3 to the power of our n minus x, so 10 minus 7. Okay, I'm going to first just figure out what that combination equals, the 10 choose 7, just doing it over here. That's 10 factorial over 7 factorial, and then 10 minus 7, which would be 3 factorial. Let's see, expanding that 10 factorial, 10, 9, 8, 7 factorial. Expanding my 3 would be 3, 2, 1. And then let's see, the 9 and the 3 could reduce. The 2 and the 8 could reduce. So that's 10 times 3 times 4. 30 times 4 is 120. Good. Okay, so I'm going to swap out my 10 choose 7. We know it's 120 now. Times 2/3 to the 7th power. Times, what would be 1 minus 2/3? 1/3, yeah. 1/3 to the 3rd power. This one, when you type it in, it's super important that you put those fractions in parentheses. It doesn't matter how you type the fraction, you just need it in parentheses. You can type it as just division. You can type it as the cute little fraction where you press alpha and then the y equals button. But it does need to be in parentheses, otherwise it only puts the exponent on the top. Alright, so we got 120 times, I'm going to put my 2/3 in parentheses. I'm just going to do 2 divided by 3, which is the same, to the 7th power. And then times my 1/3 in parentheses to the 3rd power. And is that what you got? Nice, good.
Yeah.
Okay, make sure you can get that. This is the hardest one to type in just because of the fractions. 0.2601. Which would be 26.01%. Sounds about right.